So this is the second lecture of electrostatics, and in this lecture we are going to discuss force between charges. Now before we start this, इससे पहले कि हम इसे शुरू करें, हम कुछ प्रीवियस बातें याद रखना चाहते हैं। वो प्रीवियस बातें ये हैं कि हमारे पास दो तरह के चार्जेस होते हैं, पॉजिटिव और नेगेटिव, और जो अनलाइक चार्जेस होते हैं वो एक दूसरे को अट्रैक्ट करते हैं, और जो लाइक चार्जेस होते हैं जैसे कि प्लस और प्लस वो एक दूसरे को रिपेल करते हैं, या फिर माइनस और माइनस वो भी एक दूसरे को रिपेल करते हैं. So these are some basic properties of charges that we have discussed in the last section. अगर आपने last section देखा नहीं है तो I would really want you to go and visit that last section. It is very basic, but it will help you understand and clear out a lot of things. So what is the force between charges? The force between charges is given by Coulomb's law. Let me do it with white color maybe. Okay, Coulomb's law. And what is Coulomb's law? Coulomb's law says that if I have two charges Q1 and Q2, then the force between them, or the force that one charge exerts on the other, is directly proportional to the product of charge, and it is inversely proportional to the square of distance between them. So this is an experimental law. R is the distance between them. So this is an experimental law, and you would be amazed how much it coincides with the Newton's law of gravity. If you might remember, I'll write it somewhere here in short form. Force is equals to G m1 m2 by r square. So if you might remember this, then it would be very easy to remember this one, Coulomb's law, that the force between two charges is directly proportional to the product of charges and inversely proportional to the square of distance between them. And if we write the complete formula of force, let me write this in white. So the complete formula of force is equals to k q1 q2 upon r squared, where k is equals to, where k has a value of 9 into 10 to the power of 9 in vacuum. In vacuum, and in thin air also works. So in air it also works most of the time. So k has a value of 9 into 10 to the power of 9 in vacuum. So this is a constant, just like the gravitational constant. This is also a type of a force constant. But यहाँ पे जो इंटरेस्टिंग चीज देखने की है वो ये है कि द फोर्स कांस्टेंट इज 9 into 10 to the power of 9, but if you might remember, the gravitational constant was 6.67 into 10 to the power of minus 11, and let me write the units here too, Newton meter square upon kg squared. I'll come back to the unit of k, but for now I want you to understand the comparison between these two. So the comparison is actually fairly simple to make. If I have two masses, 1 kg and 1 kg each, separated by a distance of 1 meter, there will be an attractive force between them as given in the Newton's law of gravitation, and that force will be equals to G into 1 squared by 1 squared, or simply 6.67. Sorry, this should be 6.67 into 10 to the power of minus 11 Newton. Now on the other hand, if I take two charges, maybe 1 coulomb and 1 coulomb each, both being positive, separated by a distance of 1 meters, there will actually be a repulsive force between them since both charges are positive, but the magnitude of the repulsive force is going to be k into 1 squared by 1 squared, and that will be 9 into 10 to the power of 9 Newton. So if you compare these two values, you will see that The gravitational force is a weak force. Gravitational force is a weak force. It's a weak force because the magnitude of forces between two unit masses is substantially small. If you can actually find out the ratio of force, the gravitational force versus the electrostatic force, you will get to the point where you will write 6.67 into 10 to the power of, okay, 6.67 into 10 to the power of minus 11 by 9 into 10 to the power of 9. So 6.6 by 9, and let's leave it be 6.6. What am I writing? Okay, let me write this properly for you. So 6.67 upon 9 into 10 to the power of minus 20. That would be the ratio. So you see how small, let me demarcate it, how small is the gravitational force when compared to electrostatic force. So gravitational force is a weak force as compared to an electrostatic force. So that is something you have to know about gravitational forces and electrostatic forces. Now, what is the unit of K? What is the unit of the electrostatic force constant? So we know that F equals to K Q1 Q2 upon R square. SI unit of Q is Coulomb. SI unit of R is of course meters, and SI unit of force is Newton. So Newton times some unit K into Coulomb square upon meter square. So the unit of K is going to be equals to Newton meter square upon Coulomb square, and that would be the unit of K. And this value of K, I want you to remember this value of K, 9 into 10 to the power of 9 Newton meter square upon Coulomb square, is generally valid for vacuum or air. It's not very accurate for air, but fine, we can have a comparison that it is generally valid for vacuum or air. Now we come to the next part of the situation where we are given multiple charges. So let's say we have a charge here Q, and there is a charge here Q1, and then there is a charge here Q2, and then there is a charge here Q3, and all these charges exert some force on Q, as in Q1 exerts a force F1 maybe, Q2 exerts a force F2 maybe, Q3 exerts, let's assume that Q3 charge has a different polarity, it has got a different sign, so it exerts a force F3 like this. So F1, F2, F3. So the net charge, net force on Q is the vector sum of the individual forces, is the vector sum of individual forces, as in that net force on charge Q is actually equals to F1 plus F2 plus F3, or we can say F on Q due to Q1 plus F on Q due to Q2 plus F on Q due to Q3, and this is what we call as the principle of superposition. This is what we call as the principle of superposition or vector superposition, as you might call it. Now this is a very important principle, and this principle is actively used to solve problems in forces. So मैं चाहता हूँ कि आप बहुत ही carefully इसके applications को देखें. So let's go to the applications of this superposition principle. But before we come to the applications of superposition principle, we will solve some examples, maybe some simple examples. Some simple examples. One of those examples could be, what could be the minimum force of electrostatics between two charges separated by a distance of 1 meters. So the distance between them is fixed, but you have to find out the minimum force between two charges. We do not know what the charges are. So the general formula for force, if we like to solve it here, the general formula of force is K Q1 Q2 upon R square. Now we know that K is fixed, it's a universal constant, so it is not going to change. We also know that R is fixed, that is 1 meters, so it is fixed, it's not going to change. So if we need minimum force for F minimum, we are going to have Q1 minimum and Q2 minimum. Now the question is, what is the minimum value of a charge? And we discussed this in the last topic of properties on charges, especially the last property of charges, that was quantization, that every charge is made up of a smallest unit, and what is the smallest unit? The smallest unit is charge of an electron. So that is 1.6 into 10 to the power of minus 19 Coulomb. So if you want to find the minimum force and you want to keep the minimum charge, the best case scenario to assume it is that the two charges are actually electrons. The two charges are actually electrons, and the force in between them is going to be 9 into 10 to the power of 9 into 1.6 squared into 10 to the power of minus 19 squared, or that will be equals to minus 38. I think so, yes, divided by 1 squared. 1 squared, that is the distance between them. Now all that is left is to calculate. So we are going to calculate, and what are we going to get out of it? So we know that 1.6 into 1.6 is actually 2.56 times 9, I'm guessing, and 38 minus 9 would be 29, I guess. So 10 to the power of minus 29 divided by 1 is a non-issue. You can actually do nothing by dividing by 1, it's just divided by 1. So 2.56 times 9, that's what gives us 23.04 into 10 to the power of minus 29 Newton, or we can write it as 2.304 into 10 to the power of minus 28 Newton. I think this would be the minimum force between the charges separated by a distance of 1 meters, right? So it's a simple problem. Now let's go to another problem. Let's go to another problem. The electrostatic force on a sphere of charge, on a sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. What is the distance between the spheres? What is the distance between the spheres? So this is a problem. The electrostatic force on a sphere of charge 0.4 microcoulomb due to another sphere of charge 0.8 microcoulomb is 0.2 Newton. So again we are going to apply the formula F equals to K Q1 Q2 upon R squared, and we are going to just plug in the values. That is why we are saying that these are simple solutions, simple problems. Plug in the values. Q1 is 0.4 microcoulomb. Let me tell this because this is going to be used a lot. This means microcoulomb. Now micro means in general 10 to the power of minus 6. So anytime it says a microcoulomb or a micrometer or a micro anything, you are simply going to have a factor of 10 to the power of minus 6. So 0.4 into 0.8 into 10 to the power of minus 12, because there are 2 microcoulombs in the scene. As you can see, it's 0.4 microcoulomb minus 0.8 microcoulomb, and since there are 2 microcoulombs, so 10 to the power of minus 6 into 10 to the power of minus 6, and that gives us 10 to the power of minus 12 divided by r squared. So r squared is going to be equals to 9 into 10 to the power of 3. As you can see, 9 minus 12 is actually minus 3, not plus 3. 9 minus 12 is minus 3 into 0.4, 0.8 divided by 0.2. And something of this kind is going to happen. Let's see what's going to happen. It's a fairly simple calculation actually. We can divide this and we can get a 4. 0.4 we can write 9 into 4 into 10 to the power of minus 4, and r becomes equals to root under of this entire quantity, 9 into 4 into 10 to the power of minus 4, and r becomes equals to 3 into 2 into 10 to the power of minus 2. So it's basically 6 into 10 to the power of minus 2 meters, or simply 6 centimeter is the distance between the charges. So I think that explains the concept, the simple level concept fairly, and this would be the end of video. मैंने आपसे कहा था कि हम जो वेक्टर जो उसका वेक्टर सुपरपोजिशन उस पर प्रॉब्लम्स करेंगे, बट दैट इज कमिंग इन द नेक्स्ट वीडियो. So I think I'll end the video over here. Thank you very much.